Welcome to Ancient Academy, the home of engineering and science.
Good day, listeners. This is our third class on indices. In our first class, we looked at the laws of indices. The second class, we solved examples involving indices. And this is the third class. In this third class, we shall be looking at exponential equations. Exponential equations uses the laws of indices to solve equation. Exponential equations. Exponential equations uses the laws of indices to solve equations. Now, exponential equations are equations of the form x a raised to power x equals to n. Here the index is unknown. So from the definition of exponential equations are equations of the form a raised to power x is equal to n. This is just an example. A raised to power x is equal to what? N. Where both a and n are bases. Okay. Remember in our first class we talked about base, so by now we know what bases are. And x is an exponent. X is an exponent or index, just like we mentioned earlier. So exponential equation is an equation of the form a raised by x equals to n. Now it is an equation because just because of this the sign of equation, the equation sign, the equality sign is telling us that this is what an equation. So that is just how exponential equation is. Now in this class we shall solve different examples, and you know that before now we have known that whenever we have equation, the equality sign, what it simply means that our left hand side must be equal to the right hand side. So it means that whatever we are solving, our left hand side must be equal to what? Our left hand side. So quickly, without wasting much of our time, we shall solve some examples under exponential equation. So let's start from a very simple one, just to introduce us to the topic. Let's say example. We have example. Let's say we are asked to simplify 2 raised to the power x is equal to 16. Solution. Now if you remember, I said whenever you are asked to simplify from the previous class, if you follow, whenever you are asked to simplify, it simply means that break this down, break the equation down to its simplest form. If it is an expression, break the expression down to its simplest form. For this case, it is an equation. Why? Because of the equality sign. So we are asked to break this down to its simplest form. So what we actually mean is that simplifying in this term, we have an unknown there which is what? X. Okay. So simplifying simply means look for the value of x. Simplifying simply means look for the value of what? X. So we have to simplify 2 raised to the power x is equal to what? 16. Okay. So this is a typical example of an exponential equation. Okay. So all we just have to do is just to express this. This is already in base 2. So we have to look for a way to express this in a base that will make it equal to both sides. This is what I'm talking about. So let's say we have 2 raised to the power x is equal to what? 16, right? Now you know that 16 can be expressed in base 2. Right? 16 can be expressed in what? Base 2. Remember, we can say that our 16 is equal to what? 2 times 2 times 2 times 2, right? And this is equal to 2 times 2 is 4, 4 times 2 is 6, 6 times 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is what? 16, right? So it means that 16 can be expressed as 2 raised to the power of 4. True? So if this is this, what it means is that 16 is also equal to 2 raised to the power of 4. So we can put our 16 here as 2 raised to the power of 4. So it means that 2 raised to the power of x is equal to 2 raised to the power of 4, right? Now if you look at this, because of this equality sign here, it simply means that the left hand side is equal to the what? Right hand side. provided you are having an equality sign for any equation, whether exponential equation, quadratic equation, algebraic, whatever the equation is, whenever you are having an equality sign, what it means that the left hand side must be equal to the what? Right hand side. So if that is true, automatically, since we have base 2, they are all in base. Our left hand side is in base 2, our right hand side is on base 2. Okay, so it simply means that we can equate the exponent. You can what? Equate the exponent. But if this is base 2, this is base 2. For this to be correct, for this to be called an equation, it means that the exponent must be what? Equal. Okay, so it means equating the index, right? Since we have base 2 and base 2, the index on the left hand side is what? X, right? And the index on the right hand side is what? 4. So what this means is that our x is equal to 4. Okay. Now to check, if you want to check to confirm that your answer is correct, you just bring back your answer to the initial equation. Okay. Now let's put x equals to 2. Let's just use this question to check. So now we'll get a better understanding of what we are doing. Now to check from the equation, we have that 2x is equals to 16, right? Now we have gotten our x to be equal to what? 4. So it means that 2 raised to the power of 4 is equals to what? 16. And we know that 2 raised to the power of 4 is what? Is equal to what? 2 times 2, 4, times 2, 8, times 2, 16. So it's what it means that our value for x is what? Correct, right? So that is all about exponential equation. It means that your left hand side must be equal to the what? Right hand side, and then you simplify. Are you following? So if that is the case, let's go to a more nice question. So example 2. Example 2. You have simplify 4 raised to the power of x plus 1 is equal to 8 raised to the power of x plus 2. Okay. So you are asked to simplify this solution. Now, just like I mentioned, okay, this is an equation. For an expression, whenever you are asked to simplify, first of all, it simply means that break the expression down to its lowest term. Okay. Now, for an equation, whenever you are asked to simplify, it means that look for the unknown. Okay, look for the unknown in the what? Equation. Now, if you look at this is an equation. What it means that the left hand side must be equal to the what? Right hand side. Okay. And we have an unknown there, which is what? X. And if you look at it, we have x at the right hand side, at the left hand side, and also at the right hand side. So it means that we are looking for the value of x, right? Now, if that is true, we can write out this here: x raised to the power of 4 raised to the power of x plus 1 is equals to 8 raised to the power of x plus 2. Now, if you have been following this class, if you look closely, you see that there's something very similar here. Okay, this is 4 and this is 8. True. Now, both of them have a common factor, which is what? 2, right? So it means that we can express 4 as base in terms of base 2, and we can also express 8 in terms of what? Base 2. Okay, all we are trying to do is just to make the equation simpler so that we can easily equate to get our final value, of x. So if that is the case, we have changing 4 to base 2. Okay, changing what? Our 4 to base 2. We know that 4 is equals to 2 times 2, right? 4. So it means that 4 will be equals to 2 raised to the power of 2, right? And we also know that 8 is equals to 2 times 2 times 2, right? So it means that 8 will be equals to 2 raised to the power of 3. True? So since we have known this, all we have to do is just to replace this in this equation. Replace this in this equation. If you can see, we are using the laws of indices to solve the first law we learned. We are applying those laws here. So if we are replacing this here, what we have is for 4, in terms of 4, put 2 raised to the power of 2. So we're having 2 raised to the power of 2 brackets x plus 1, right? And for 8, we put 2 raised to the power of 3, right? So we have it 2 raised to the power of 3 bracket x plus, we have 2 raised to the power of 2, present it in bracket x plus what? 2, right? So if that is the case, what you have to do according to both parts, bracket first, we want open our bracket, okay? So we now have 2 raised to the power of 2 times x, okay, is 2x, right? 2 times 1 is what? Plus 2 is equals to 2 raised to the power of 2 times 3 is what? 3x. 3 times 2 is what? Plus 6, right? So we have gotten this just like we did for our first example. This is in base 2 and this is what? In base 2. Because we have an equal sign here, equal to sign, it means that both the left hand side and the right hand side must be what? Equal. And if that is true, we have this base 2, we have base 2. So it simply means that the exponent must be what? Equal. The exponent of both sides must be equal. So it means that what we have to do is just to equate the exponents. Okay, so again, we equate exponents. So if you equate the exponent, we'll be having what? 2 raised to the power of x plus 2 is equals to 3x plus 6. 2x plus 2, which is the exponent at the left hand side, plus the exponent at the right hand side, which is 3x plus what? 6. Right? So if we get that, we can solve from our normal algebraic equation. Okay, we take like terms. Now we are taking like terms, it means that those with x will come over one side and the negative ones will go over what? The other side. So let the x come to the left hand side. So we have 2x. Now if 3x is moving to this side, each sign will change, right? 3x crossing an equal to sign. Remember, it has a positive sign here. When it crosses an equal to sign, it will each sign will change. So if you cross it, we now have minus 3x, right? And equal to, we have our plus 6 here. So that's our 6. Now, at the left hand side, we have plus 2. Plus 2 is crossing an equal to sign, so this sign will change, right? Towards minus what? 2. True. So if that is the case, we now have minus 2x plus minus, we now have 2x minus 3x, right? 2x minus 3x. We now have 2x minus 3x, and that will give us what? Minus 1x. True. Why? Because the sign having a negative sign is bigger. So what we do is what? 3 minus 1, which is 3 minus 2, which is 1. And we bring out the sign of the bigger one, right? Just like you are owing someone 3 naira and you pay 2 naira. Okay, you have 1 naira left. Your 1 naira is the minus here is telling that you are still owing that person 1 naira. Are you following? So this is minus 1s is equal to 6 minus 2, which is what? 4. True? But remember, we are asked to look for x and not minus 1x, right? So what we do is to divide both sides by minus 1. So that we'll get the value of x. So we'll divide both sides by minus 1. Sorry, by minus 1, right? So we do that to have minus 1x all over minus 1, right? Is equals to 4 all over minus 1. True. So if we divide this, we now have what? This will cancel out. So we have x here is equals to, now 4 divided by minus 1 will give us what? Minus 4. So it means that the value of our x here is what? Minus 4. Okay. Now let's go to another question. Nice question.